So HRM-Text-1B just dropped on Hugging Face. A 1B model trained on 40 billion tokens that apparently beats Llama 3.23b on several benchmarks. Is this real, or did someone just overfit on a benchmark suite?
Not overfitting. The model uses a completely different training recipe. It learned exclusively on instruction response pairs, not raw web text. The architecture uses two recurrent stacks running at different timescale. The design is what makes the efficiency possible.
But a 1B model trained on 40 billion tokens beats a 3B model trained on nearly a trillion tokens. How is that physically possible? Where does the extra capability come from?
The limitation is not the architecture. The limitation is that the model was never trained on broad web text. It has a 60.7 on MMLU, below every comparable model. The factual knowledge gap is real. The reasoning wins are real. Both are true at the same time.
Wait, so the model thinks through problems better, but knows fewer facts. That means the entire assumption about scaling laws may be measuring the wrong thing.
That is exactly what the paper argues. Scale is not the only path. The architecture and training objective together determine what kind of intelligence emerges. And the $1,500 price tag means every research lab can now test that hypothesis themselves. A 1B parameter model just trained on 40 billion tokens and $1,500. It scores 84.5% on GSM-8K, beating models that consumed 1,000 times more data. Not a prototype, not a simulation. A live Hugging Face checkpoint you can run today. The benchmark sheet reads like a revolution. HRM-Text-1B scores 84.5 on GSM-8K, 82.2 on Drop, and 81.9 on ArcChallenge. That puts it ahead of Llama 3.23b, Quinn 3.52b, and within striking distance of Gemma 3.4b on several tasks. But it fails where others win. HRM-Text scores only 60.7 on MMLU, below every comparable model in its class. The reason splits the entire story in half and changes what this model actually represents. HRM stands for Hierarchical Reasoning Model. Two transformer stacks operate at different timescale. The high-level slow stack and the low-level fast stack iterate 2 by 3 times each, passing additive state back and forth. Bounded parameters, unbounded effective depth. The training data is not web text. The model learned exclusively from instruction response pairs. Every training example is a task with a correct answer. This is not how Llama was trained. This is not how Quinn was trained. It is a completely different objective. The architecture combined with the task completion objective produced something unexpected. Recurrent depth lets the model deliberate without adding parameters. At inference time it runs 8 effective steps per forward pass. The GSM-8K score reflects this. The paper claims 96 to 432 times less training compute than comparable open models. Trained on 40 billion unique tokens. Llama 3.23b was trained on 958 billion tokens. The $1,500 budget is not a demo. It is the actual final cost. The conventional assumption was that raw text at scale is the only path to useful language understanding. HRM-Text does not just use less data. It replaces the entire training paradigm with task completion pairs and PrefixLM masking. If a 1B model trained on a $1,500 budget can enter the performance range of models that cost hundreds of millions to train, the barrier to foundational LLM research just collapsed. Not lowered, collapsed. The question is not whether this model is the finished product. It is what happens when every research lab on Earth can afford to train foundation models from scratch. The compute moat that protected big labs may have just become optional.
Yeah, the benchmarks that won and the one that did not tell two different stories. Both matter. Subscribe if you want the next one before the paper trail gets crowded.